In lecture 1, we already discussed about the PC version of SPICE model. In PC version of SPICE model, we can describe all the circuit using programs, and these programs will save a file with the extension .cir, or we can draw our circuit in a workspace as a schematic diagram, and this file will save us with the extension .sh, or we can use the SPICE version, and the SPICE version is known as OrCAD capture. In OrCAD capture, the schematic diagram will save us with the file extension .opj. Then this OrCAD capture schematic will directly go to SPICE and another digital engine, and it will directly give the output of probe. For the PSpice schematic will generate the netlist. The netlist file is same as that of the .circuit file. System will automatically generate the netlist file from the schematic diagram. That means either we can draw the circuit in the workspace of the PSpice, and this circuit will save as a file with the extension .ch. Then the system will generate the netlist of this schematic diagram. Or we can give a program that mentions the circuit. This program is known as circuit description. The circuit description consists of the title of the program, or program title, or title of the program, then the circuit description, then the analysis description, what type of analysis we are going to this circuit. This is circuit description, output description, and end of the statement, that is .end. All the PSpice commands are starting with the dot. So the commands are known as commands. Here the end of the bottom line of the statement is denoted by the description .d. Now we are going to discuss different commands that we can use in SPICE simulation software. This one is type of output commands. The different output commands using in SPICE software is .print command, which is used to print out outputs. That means node voltages, branch currents, node source current, source voltage. For printing different outputs, we can use .print command. If we want to plot our output or any other parameter, electrical parameter, we can use the command .plot. But plot command will plot the outputs. Next is the .plot command. .plot command also will plot the waveforms. And .pick command. .pick command is also an output command. First we will discuss about the .print command. The result of analysis in the form of tables. It will print the result of analysis in the form of tables. The maximum number of output that can be printed in a single output stream is 8. We can use more than one .print command. Syntax of the .print command is .print DC, then in bracket the name of the output variables. For example, we want to print the DC voltage V2, that is the voltage at node 2, then voltage across the resistance R1, then voltage across node 3 and node file. Let us see meaning of this print command. For example, let us see this example. This is the circuit. We can develop the .circuit file as first is the heading of the .circuit file, that is DC chip. DC chip is the heading of this title of the program, and there is a voltage source with the name VS that is placed in between node 1 and node 0. It is a DC source and its value is 1 volt. Then there is a current source in between 0th node and second node, that is current flows from node 0 to node 2. And it is also a DC source and its value is 1 milliampere. Then there is a resistance R1 in between first and second node, its value is 1 kilo ohm. Then there is a resistance R2 in between node 2 to node 0 or 0 to 2, its value is 2K. Then we are going to perform which analysis? DC analysis. So the command for DC analysis is .dc. .dc due to the voltage source Vs, DC analysis. Then we will perform the DC analysis from 1 unit time to 6 unit time with a step size of 1 unit time. The analysis will perform from 1 unit time to 6 unit time with a step of 1 unit time. Then the output will print. What are the output? We need to print the current I to the voltage source Vs, then node voltage between 1 or voltage between the node 1 and 2, then voltage at node 2. Then we will end the program using the command .end. Then after the simulation of this program, you will get an output window which looks like this. Then we ask them to perform the DC analysis. Then unit time starting from 1 unit time to 6 unit time. That is our DC analysis will start from 1 unit time to 6 unit time at a step size of 1 unit time. That is, it will show print the current. What are the parameters? We need to print the current to the source Vs, then the voltage across node 1 and node 2, then node voltage V2, voltage at node 2. That will print the software or simulation software. Simulation will print the current due to voltage source Vs, then node voltage between 1 and 2, and voltage between node 1 and 2, then voltage at node 2. After simulation, the software will print these parameters, that is from 1 unit time to 6 unit time, that is step size of 1 unit time. This will be the output of this program. This will perform the DC analysis in this circuit. That is .print command will print the outputs. Next we will see the .plot command. The .plot command will plot the output. The .plot command shows the result of analysis in the form of line printer plots, that is using characters. It will plot the result using characters. Maximum number of output variables is equal to 8. Only 8 variables we can plot. More than one .plot command can be used in a single simple program. The syntax is dot plot DC in bracket square bracket comma. After a space, we can keep the output variables. For example, dot plot DC, which are plot we need to plot in the output screen. That output variable we need to write. This V2 means node voltage at node 2. VR1 is the voltage across the resistance R1. V3 5 means voltage between node 3 and node 5. For example, we'll see an example, same example. This is the program. In this program, we are going to perform the DC analysis. DC analysis is denoted by the dot command dot DC, and the step size is also given in dot DC command, that is from 1 unit time to 6 unit time in the step of 1 unit time. We will both print here. We can give dot print command as well as dot plot command in the same program. Here we are going to plot the node voltage V2, and here we are in this program using the command dot end command. Okay, then and dot plot command will plot the node voltage V2 as well as it will print the node voltage V2. This is the node voltage V2 in input form, and it will also plot like this, as it will plot the node voltage V2 using symbols. Using symbols, it will plot, or using character, it will plot the node voltage V2. This is the output window of this program. Okay, this is the dot plot command. Next is dot prop command. Dot prop command is graphical waveform analyzer. That means it looks like a CRO output. CRO output. That means the system will smoothly plot the output of the circuit. Simulation results cannot be used directly in the prop command. That means before the prop command, we need a analysis command. Before the prop command, we need an analysis command. The syntax of the dot prop command is dot prop the variables, different variables. Dot prop. Let us see an example. This is a piece-wise program to simulate the step response of transmission line integrated converter station represented by L and C. This is the program. We are going to perform the transient analysis. The command for transient analysis is dot trans. TRAN. Dot tran is the command for transient analysis. We will perform the transient analysis from 1 microseconds to 10 microseconds, and the result should have to outputted using the command dot probe. And this is the output window of this command. The simulation software will output the result from 0 microseconds to 10 microseconds. This is the transient analysis of the transmission line. This is the output of the dot probe command. It looks like a perfect waveform. Next output command is dot print command. In dot print command, if you want to state the output column width, we can use the dot width command. We can set the width of the output column using dot width command. The value must be either 80 or 132. Default it is 80. By default it is 80. We can set